Deep learning techniques have significantly boosted the performance of image classification tasks. This success is mostly attributed to the availability of enormous amount of data. However, it is unlikely to collect the data for every class in the real world. In the zero-shot learning setting, images of some classes are unavailable. Thus, zero-shot learning is intrinsically a data missing problem. Thanks to the advanced development of generative models, especially GANs, we can synthesize unlimited image samples to augment data missing classes. Further, with the synthesized data, zero-shot learning problem can be converted to a supervised classification problem. Existing methods using generative adversarial approaches for zero-shot learning aim to generate realistic visual features from class semantics by a single generative network, which is highly under-constrained. As a result, the previous methods cannot guarantee that the generated visual features can truthfully reflect the corresponding semantics. To address this issue, we propose a novel method, namely cycle-consistent adversarial networks for zero-shot learning. It encourages a visual feature generator to synthesize realistic visual features from semantics, and then inversely translate back synthesized visual features to corresponding semantic space by a semantic feature generator. Furthermore, a more challenging and practical ZSL problem is considered where the original semantics are from natural language with irrelevant words instead of clean semantics that are widely used in previous work. Specifically, a multimodal consistent bidirectional generative adversarial network is trained to handle unseen instances that leverage noise in the natural language. A forward one-to-many mapping from one text description to multiple visual features is coupled with an inverse many-to-one mapping from the visual space to the semantic space. Thus, a multimodal cycle consistency loss between the synthesized semantic representations and the ground truth can be learned and leveraged to enforce the generated semantic feature to approximate the real distribution in a semantic space. Extensive experiments are conducted to demonstrate that our method consistently outperforms state-of-the-art approaches on natural language-based zero-shot learning tasks.